Hi again, physics. This is the second part of the video. Hopefully I can finish it all here. This video might take us step 3, or part 3, we'll see. So yeah, again, this is Alice and Billy pushing the crate across the lake. We've already done step We've done step 1, the sketch. We've done step 2, our free body diagram, but we found out we had an ugly vector. So to that ugly vector we had to do a step 0, find the pretty components of the ugly vector. Then we went back, we did step 2 again, and now we have a free body diagram that only has the pretty components. So we're ready to move on to step 3. So let me move that out of the way. Alright, so step 3, let's go back to black for this, is going to be Newton's second law. This is the most important thing you'll learn in physics all year. And when you're doing these two-dimensional force problems, you do the y side first. So what this is going to be, F equals ma, but these are vectors, they need to wear hats. This needs to be sigma F equals ma, F and A are wearing hats, and really this should have a subscript y, and this should have a subscript y. So first things first, let's think about what's going on. We're going to go back to the sketch. With the acceleration in the y direction. So if we look at this sled, it's accelerating to the right. It is not accelerating in the y direction at all. The sled is not accelerating up, it's not accelerating down, it's not flying into the air, it's not digging into the ice. So what that means is that a sub y is going to be 0. So when I rewrite this, the whole right side of this is going to be 0. So what is the left side going to be? Sigma F sub y. So to get that term, go back to your free body diagram, the good one, grab all of your forces that are going in the y direction. So I'm looking, and that's going to give me this guy, and this guy. These are the forces in the y direction. All of these forces are going to wear hats, and they're all going to be plussed together. So what I have over here, sigma F sub y is going to become F sub n with a hat plus F sub by with a hat plus F sub g also with a hat. Remember, when you're doing step 3, everything wears a hat and everything gets a plus. So now on to step 4 on the y side. So step 4 is math. The first part of math is take your hats off and put in your signs. So I've got to figure out what signs are going to go with F sub n, F sub by, and F sub g. So if I look at my sketch, F sub n is going up, so that's going to get a plus. F sub by is also going up, so that gets a plus. And F sub g gets a minus because that one's going down. So now that I take off my hats, that's going to give me F sub n plus F sub by minus F sub g. And all of this is going to equal to 0. So the thing I'm looking for here is F sub n, so I want to do some algebra to get F sub n by itself on one side. That's going to give me F sub n is equal to, and on the right side I'm going to have minus F sub by plus F sub g. So you've got to be real careful with the signs here. Minus F sub by. Well, F sub by I already figured out. That's what I did back in step 0. So that's going to stay like this. At least for now, I'm keeping it in letters. F sub g, I'm going to replace that with my formula for F sub g. That's on the footer of all the homeworks. And that formula is mg. Very common mistake is people accidentally just replace that with 9.8. Well, that's just g. Other people might replace it just with the mass. That's not the force of gravity either. Mass is different than weight. So be careful about that. So now I've got to go to my numbers. So F sub by, well, technically minus F sub by, is going to give me minus 112.5 newtons plus my mass, which is 90 kilograms, times gravity, which is 9.8 meters per second squared. So if I do that all in my calculator, and I'm very careful about the signs because I do have that annoying minus sign there, If I plug all of that stuff in, I'm going to end up with 769.5 newtons. So then I put a box around it, and I do a quick step, did I solve for the right thing? Did I give it the right units? If we go all the way back to this screen, yeah, I wanted normal force, and I wanted it in units of newtons, so that's good. Is that a reasonable number of newtons? That's a little harder to tell because we don't often really do our forces in newtons in the real world. So we don't have a lot of regular experience with that, but that is a reasonable normal force. So that makes sense. The next thing we're going to do, I want to be a good color. I'll go blue this time on top and then black underneath, is we have to do step 3 on the x side. So again, step 3 is going to be Newton's second law, F equals ma, but we need hats because everything was a hat and all the vectors were hats, at least in step 3. We need sigma F, sum of the forces, and this is in the x direction. So I need these subscripts too. Now this time, if I go back to my picture, all the way back to my step 1, this sled is moving to the right. It might be accelerating to the right, so I can't assume that a sub x is 0, and it turns out it's not going to be 0. So it doesn't cancel out the way it did in the last one. So that means the right side of this is, at least for now, is just going to stay m a sub x with a hat. Now the left side. Go back to our step 2, the good one. Grab all of your x forces, so f sub k, f sub bx, and f sub a. We're going to put hats on all of them, and we're going to come back here and we're going to plus them all together. So starting left to right, that was f sub k with a hat plus f sub bx with a hat plus f sub a with a hat. So from here, what do? We go on to step 4 on the x side. Step 4 is math. In a force problem, the first part of math is take the hats off and put in the signs. So let's look back at our free body diagram. F sub k, this guy is going to the left. He's going to end up with a minus sign. These other two guys are going to the right, so they're going to end up with plus signs. So I come back here. This is going to become minus f sub k, no hat, plus f sub bx, because it's going to the right, plus f sub a, that's also a plus because that's going to the right, is equal to m a sub x. And it's a little point, but I actually have to guess which way we're accelerating. I'm going to guess we're going to the right, which means a sub x, when I take its hat off, also gets a plus. So if we look at this, the thing we're trying to solve for is a sub x. So the algebra that gets a sub x by itself is just divide everything by m. So I'll actually do it right here to save space. I divide the left side by m. I divide the right side by m. So now the m's go away. So on my right side, I just have a sub x by itself, which is what I want. Now if I look at this, most of these numbers I already know at this point. F sub bx, I figured that out back in step 0. F sub a, I knew that from the beginning. M I knew from the beginning. It's f sub k that I have to actually figure out. So if you look at the footer of any one of the homeworks, f sub k, there's a formula for that, and that formula is minus mu sub k times f sub n. So mu sub k we knew from the beginning. F sub n is this number that we just figured out down here. So that's now good, plus f sub bx plus f sub a, all of this divided by m. And this is going to give me a sub x. So I know what all these numbers are. If I plug them all in correctly and do the calculator part correctly, this should give me the right answer. So I'm going to switch left and right to make this a little bit easier to write at this point. And I'm going to say a sub x is equal to minus mu sub k. So that's minus 0.100 times my normal force, 769.5 newtons. I hope I have enough room. Plus f sub bx. If I go back to my step 0, That's this number right here, 134.1 newtons. Plus my force of Alice. That I knew from the beginning. The force of Alice is 225 newtons. All of this divided by the mass. And the mass of this was 90 kilograms. So when you're doing this in the calculator, there's a few ways to get this wrong if you don't get the order of operations correct. So what you want to do, at least one way to do it, is put a big parentheses on the top so that you're doing all the addition in your numerator and then dividing the whole numerator by the denominator. If you don't have the parentheses or if you do it wrong, you might not end up doing that. So if you do all of that stuff, what do you end up with? A sub x is equal to, and the number I get, 3.14 meters per second squared. And I put a box around it. And now it's time for step, did I solve for the right thing? Did I give it the right units? Let's start with that. So go back to step, Yeah, I wanted a sub x, and I wanted it in meters per second squared. So if I look at that, that seems good. Is 3.14 meters per second squared, is that a reasonable acceleration? That seems pretty reasonable. It's not as fast as something would fall if you dropped it off a cliff. Again, these are people pushing a crate, so that kind of seems like a reasonable number. It should be less than our number for g. So I'm happy with that number. That seems correct. So hopefully this all helped.